Hello, my name is Thomas, and I'm going to talk about the load feature. So I'll show you, we're going to enable the load command. So we're going to click the load button, and this allows you to load a video outside of the current directory, which is beta 6.0. So we're going to load the video from the desktop right here. So we'll let MATLAB start loading that. We have dynamic text displaying that the video is now buffering or loading. The reason our video buffers, our GUI buffers, is because we want to achieve the correct frames per second for the video. So this is achieved with two different loops. One of them is on the load button. So this is the buffering command essentially. What we're doing is we're pulling each frame of that movie with the item read command, and we're storing each and every frame into a structure, which is being incremented by this for loop. Basically what we're doing is we're filling a bin with all the video files, and then what we want to do after it's done loading, the user will be noted that the video is done loading, and then we're going to use the while loop to item show each and every one of those frames from that bin. This allows us to achieve the correct frame rate if we increment a pause with 1 over the frame rate of the video itself in this while loop. So this display right here shows you the video playing at the correct frame rate, smooth and crystal clear, 25 frames per second. This desktop, on the other hand, has the special features, which we'll talk about a little later. The reason we didn't show you it on this laptop is because the special features slow down the playing capability because of limitations in hardware.
Hi, my name is Joshua Rivera, and I worked on the play and pause button, the step forward button, the step backward button, and the stop button. So the play and pause button, what they basically do is like when it's in the play state, the user data is play. This is like when you initially hit the play button, and then afterwards when you hit it again, then the state of the button, or the user data in this case, becomes pause. So when it's in the play state, then the frames cycle, or the video cycles through the frames in a while loop, so through the item show function. Also, I also worked on the stop button, and when you hit stop, the state of the play button becomes pause. Stop, sorry. And so when you hit the pause button, regardless of where the state is, whether it's pause or play, it automatically goes to stop. And what this does is that it resets the current frame to 1. So when you hit play again, it starts from the very first frame. So I will show the code here now. When you hit play, it plays the video. Then you can hit stop, and it'll cycle back to the first frame. And if you hit play again, then it'll play. Also notice that when I hit the play button, the text changes and pauses itself. The other two features that I worked on is the step forward and step backward button. And basically what the step forward button does is that it cycles 1 frame. So if you hit the step forward button, you can notice how the bunny moves his arms because it's cycling to 1 frame forward. And when you go press step backward, then it goes 1 frame backwards. And how this works is basically it takes the current frame that it's on and it adds 1 to it. Or in the step backward case, it minuses 1.
My name is Shubhankar, and I worked on the slider for this project. What the slider does is, using a get command within the callback function of each push button, I get the current frame handle and I set the value of the slider to that current frame. So when the video is being played, the slider callback function is just moving with the current frame that we were at. When it's paused, it's getting the current frame that the video was paused at, and it's setting the value of the slider to that frame. When the step backward or the step forward buttons are used, the slider uses the same functionality. It gets the current frame, updates itself. Same thing with the stop button. The slider also has a reverse functionality, which means that if the slider is moved, the video resets itself to the position that the slider was moved to. For instance, now this sets the current frame to the value that the slider was moved to, and the video will resume from the position that the slider was set at. The slider also updates the special features. I worked on the first special feature, which is the RGB histogram special feature. What this special feature does is that from within the handles S from within the S structure, it pulls each frame, and for each frame it pulls the red channel using this function, it pulls the green channel using this command, and the blue channel using this command. And for each of these channels, it finds the number of pixels that have a certain value between 1 and 255, and it plots that as a function of 1 to 255. So it basically tells us the saturation of each color within the frame that's being seen. The reason the S structure was used is that when the video was loaded, the frames field within the S structure was being populated, and so the RGB histogram function just defines a new field within the S structure thus. So it updates itself, pulls the frame, and it defines the new RGB field, and when the feature is being played, it pulls that frame from within the RGB structure, and IM shows the C data that corresponds to that frame onto the special feature 1 axis. The special feature can be enabled and disabled by the user. The way this was achieved was with the use of state diagrams. So when this is disabled, a default image is displayed, and when it's enabled, the feature displays again. This was done using the use of state diagrams. When the button is pressed, the user data on that button changes itself to disabled or enabled, and using a conditional if-else statement with the play button, the functionality for the special features was achieved.
So I'm going to talk a little bit more about why the special features are slowing down the computer, and special feature 2, which is the sharpened image in the top right hand corner. The reason that special features are slowing down both the buffering, which we have a difference in buffering, 210 seconds to load the video with special features and only 40 without. The reason for this is because with the special features, both of them are taking every frame of the video we're loading into MATLAB, doing mathematical operations on them, and then storing those in structures. So 3 of those things is happening at the same time. And then when we play them, it's displaying 3 different things all at the same time. So we have some slowdown there. Now I'll explain special feature 2, the sharpened video. So basically what this is it's taking, once again, every single frame and applying a mathematical operation. I'm making use of the convolution function to do this, but I also have the code for the full algorithm. It's just way too slow to test and to use without knowledge of DSP theory. So I'll explain kind of what convolution is doing. So the 2 things it needs is it needs a kernel matrix, which is a 3x3 matrix, and it needs the frame. We're going to look at just the red frame. One frame, the red layer of the red frame. What the convolution function is doing is it's taking a pixel. So we'll start with this pixel up here. And it's adding zeros all the way around this corner of the pixel, and then these neighboring pixels are here. So we'll pretend this pixel has a value of 3, and neighboring up here on the edge of the image is all 0, padded with zeros. And then we'll pretend these neighboring pixels are 1, 2, and 3 here. What the convolution function is doing is multiplying first this matrix that just snapshotted from the red image, multiplying it with the kernel. So the 3 value is being multiplied by 5, so it's being intensified. These other values are being multiplied by 0, and these other ones are being multiplied by -1. And it's taking the average of that multiplication, and it's giving you a new pixel value, which in this case with these numbers is a decimal. Then what we're doing is we're taking the original image and we're adding that new kind of sharpened layer to it, and this is going to give us a completely sharp pixel. Adding those 2 layers of the image will give you a new frame that has been brought up in intensity. So it's the original image plus this kind of convoluted image added together. And then what we're doing all within the same loop with all this math is we're adding this into a new structure. Once again, why this is so slow. We're adding this into a new structure which can then be referenced with IM show in our play loop. Just like special feature 1, when you play the video, we'll go back to the beginning here. When you play the video, it plays along. Again, notice how slow it is just because hardware. When you move the slider, it updates the frame. And when we stop and we play again, everything that happens with the main axis is happening with this special feature. We can also disable it, and you get some nice pairs there. And that concludes the video for our project.